All right, let's go ahead and take a look at this. As you know, this doesn't take long. This is our sample exam. Your regular exam will look a whole lot like this, except, of course, be different. The quiz number 2 is online. Quiz number 2 is a little challenging. So, but you have unlimited attempts. So, just do your best, get as many points. Blackboard will save your highest score. Again, it draws from a big database of questions, and some of those can be a little tricky, but just do your best with them, and we'll see.
How many questions?
On the quiz, 20 questions. 1 point each. All right. In which of the following are the name, the formula, and water solubility properly matched? Well, iron 3 chloride, let's start here. If iron was a +3 and chlorine is a -1, I don't think it's going to be Fe2, is it? Because that would give us 6 positives here, only 3 negatives. Iron 3 chloride is FeCl3. So that's not right. Everyone see that. Soluble in water, that's right, because most chlorides are soluble in water, except for heavy metals, lead, silver, mercury, whatever. Ammonium sulfate. Well, the ammonium part is right, but this is hydrogen sulfate, isn't it? Remember, sulfate is a +2 charge. I'm sorry, a -2 charge. Ammonium is a +1, so we would need 2 of them, but ammonium sulfate would look like this.
So it's also wrong.
It's wrong.
Okay. See, I didn't know you could have multiple answers.
Calcium sulfate. Well, calcium is a +2, sulfate is a -2. So that looks right. That's the correct formula. However, the solubility. Remember, most sulfates are soluble in water, except for calcium, barium, and what is it? Is it lead? It's one of those. Could be copper. I don't know. No, copper is soluble. But this is wrong because calcium sulfate is one of the insoluble guys. Aluminum chloride. Well, aluminum is a group 3 metal, so it's a +3 cation. Chloride again is a -1, so we would need 1 aluminum and 3 chlorides. Not that. So that's wrong.
That's wrong too.
And our last guy, mercury 2 chloride. Mercury here is a +2, so we would need 2 chlorines, and that works. Insoluble in water. Well, remember, most chlorides, most halides are soluble, except for mercury, silver, lead, and copper.
A through D is the answer. You said most chlorides are insoluble?
Most of them are soluble, except for these guys. And remember, you get your 3x5 card. So if you want to make little tiny notes on it, something like that, to help you remember those things. I get them confused sometimes too, but any questions? All right, we're doing mass percentage here. Very simple compound. It's just manganese 2 oxide. Manganese is a transition metal, so we have to use the 2. But this works, manganese 2. This is the molar mass, 70.94 grams per mole. And we're given, and you can look it up on the periodic table, but here's manganese and here's oxygen. Remember when we do this, to get the percentage composition, all in the world you have to do is divide the molar mass, so in this case manganese, by the mass of the compound. That will give you the fraction. To get a percentage, you multiply by 100. So, for manganese, molar mass is 54.93. Mass of our compound is 70.94. Our percentage would be 77.4. The fraction is 0.774. For oxygen, our molar mass is going to be about 16 per mole. Again, the same thing, we're going to divide it by the total mass of the compound. When we do this, our fraction is 0.226. Multiplied by 100, we get 22.6%. You will have a problem very similar to this on your exam, so make sure that you just understand the procedure, okay? The molar mass of the element divided by the total mass of the compound. All right, here we have a mass of 37.8, and we have 0.2 moles of the compound. What is the molar mass? Well, think to yourself, what is the definition of molar mass? It's grams per mole, isn't it? Here we have grams, and we have moles. To get grams per mole, we simply have to divide them. So the math is going to be our 37.8 grams divided by our 0.2 moles. Simple calculation. And we're at 189 grams per mole. That is our molar mass. Simply remember, mass divided by moles is molar mass. All right, we have an element, and we have 6.5 grams of it. We're told that this contains 0.1284 moles. What's the chemical symbol? Now, what we want to do here is to simply figure out the molar mass, just like we did in the previous one, right? Because the molar mass of the element is going to be the average atomic mass shown on the periodic table. So here we have 6.54 grams and 0.12 moles. Take the mass and divide by the number of moles to give us the molar mass. Just like before.
Oh, sure, go ahead.
Oops. Just like the previous problem, mass divided by moles gives us molar mass. Okay? So we're going to take our mass, that's 6 grams divided by 0.12, and we wind up with 50.94 grams per mole. Now, once we're here, all we have to do is look at our periodic table and find an element that weighs 50.94 as its average atomic mass. And as I look, we're going to be in here somewhere, 50.94. Oh, there it is. vanadium. So you were asked to simply write the symbol. The symbol, of course, is just V. Now, make sure that you understand the logic here. We were given mass in moles, we did molar mass, and then simply match that up with the periodic table. Any questions? How many hydrogen atoms do we have in half a mole of ammonia? Well, we remember that a mole of anything is 6.02 times 10 to the 23rd, right? All right, so here we have half a mole. So it's going to be half of that, 3 times 10 to the 23rd, right? Except we have 3 hydrogens in every ammonia. So we're going to have to multiply that by 3. Here's what the math looks like. Convert the number of moles to atoms. So we have half a mole. Going to convert that to the number of atoms. Then remember that there are 3 moles of hydrogen per ammonia. And we're simply going to multiply that then by 3. So we have half a mole. We know that every mole is 6.02 times 10 to the 23rd. But because there are 3 hydrogens, we have to multiply this guy by 3. Our moles cancel. All we're left with is hydrogens. So it's going to be 6 times 3 times 0.5, or 9 times 10 to the 23rd. Now you should have been able to actually do this one in your head, just like we talked about. We have half a mole, it's going to be 3 times 10 to the 23rd, isn't it? We have 3 hydrogens, so we multiply it by 3, and that gives us 9. Now it doesn't match anything, so it's the dreaded none of the above again, isn't it? Any questions? How many atoms in 0.27 moles of water? Pretty much the same sort of question as last time. We know the number of moles. We know how many things there are in 1 mole. That's 6 times 10 to the 23rd. So we're just going to multiply those together. But there are 3 atoms in every water. So once we multiply that, then we have to multiply by 3. 3 moles of atoms in every mole of water. We simply take our number of moles, multiply it by 3. Oh, the question was moles, not actual atoms, was it? So this is even simpler. 0.27 moles times 3 atoms per water. Just multiply them and you get 0.81. In 1 mole of water, or in 0.27 moles of water, it'd be 0.27 oxygens, wouldn't it? 0.27 moles of oxygen. And there would be twice that many, so that's 0.54 moles of hydrogen. Add them all together, you get 0.81. Everyone happy with that? All right, here we are reacting copper to sulfate and barium nitrate. What we want to do is to predict the products of this reaction. Now both of these are going to be aqueous solutions. So this is a double replacement reaction. Remember, in a double replacement, what you do is just simply swap ions. So here's the reaction we're doing. A solution of copper sulfate, a solution of barium nitrate. If we swap these ions, the copper is going to pair with the nitrate and the barium with the sulfate. Now remember, most sulfates are soluble, except for calcium, barium, and somebody else. Barium sulfate is our precipitate. Copper 2 nitrate is what we form here. And barium sulfate is our other product.
I can't see. Thank you.
Simple double replacement. All you do is swap ions. And if you don't get a solid, then nothing happens, right? It's not a reaction unless something happens. Any questions? All right, we get to balance an equation. Yes, you will get to balance an equation on your exam. And when you do the quiz, there'll be lots of them. And some of them are a little bit bizarre, but just do your best to deal with them. Let's see. We look at this guy. First thing that catches my eye is that we have 3 oxygens here, so an odd number, and only 2 on this side. So probably I would start off by doubling this. Now when we do this, we have put in 6 oxygens total here, haven't we? So since there are 2 in every CO2, we need 3 CO2s. So now our oxygens are balanced. We have 4 irons here, but only 1 on this side. So let's fix that. And now, if we're going to make 3 CO2s, that's 3 carbons, right? So we're going to need 3 in front of our carbon. And it worked. Any questions?
Wait, how we get the 4 irons again?
Well,
like 2 times 2.
We have 2 times 2.
Right.
So that's got to be a 4. All right, once again, we are calculating a molar mass. Again, we have so many moles, and we have so many grams. Remember, molar mass is simply grams per mole. So we're going to take our mass of 125 grams, divided by our number of moles, and that will be our molar mass. This is by definition, grams per mole. 125 grams, and we're given we have 3.68 moles. Simply do the division, nothing cancels. Do the division, and we have 33.97 grams per mole. Simply remember your definition. Grams per mole, molar mass. Any questions?
Said grams per mole equals molar.
That's it. Grams divided by moles gives us molar mass by definition. All right, this is a single replacement reaction. Remember, in a single replacement reaction, we have a rule of thumb that generally works. And that's metals replace metals, and non-metals replace non-metals. We have an element and a compound, because a single replacement, we're going to make a metal and a compound. Because it's a single replacement, once again, the metal is going to pair up with the ion here, going to replace it in the copper nitrate, and the copper is going to turn up as our metal. Metal and a compound, metal and a compound. Are these redox reactions? Is this a redox reaction? It's a very simple rule you can remember.
Yes, please.
Very simple rule. Anytime you're taking an element and making something else from it, because an element always is defined as 0. And you make something else, it's not going to be 0. I don't care what it is, but it's not going to be 0, is it? So that must be redox. If you have an element on either side, it must be redox. We have 0.863 moles of SO3. How many grams of oxygen are there? Well, there are 3 moles of oxygen in every SO3. Correct? We have 0.863 moles of compound. So we're going to multiply moles of oxygen by the molar mass of oxygen. All right, so we have 0.863 moles, correct? There are three oxygens in every mole of compound. So that's going to be 3 times that. That will give us how many moles of oxygen we have. And we know that every mole of oxygen weighs 16. So here's our logic. We have 0.863 moles, right? In every SO3, there are 3 moles of oxygen. So we're going to multiply it by 3. Our moles are going to cancel here, so we're just dealing with moles of oxygen. And we know that every mole of oxygen weighs 16. So we simply put that in. This set of moles is also going to cancel, and all we're left with is grams of oxygen. So the math is fairly straightforward. 0.863 times 3 times 16. And the answer is 41.4 grams. Appreciate the logic of it, though. We know how many moles of sulfur trioxide we have. That means we must have 3 times that many moles of oxygen. And every oxygen weighs 16. So 0.863 times 3 times 16. Any questions? All right, we have 6 times 10 to the 21st atoms of an unknown element. The sample has a mass of 0.558. What's the element? All right. This is 6 times 10 to the 21st. How many atoms are there in a mole? 6 times 10 to the 23, so 100 times more, right? 100 times more. So just logically here, just logically in your head, if 10 to the 21st weighs 0.558, a mole is going to weigh 100 times more than that, isn't it?
So you move it over to decimal digit.
It's 100 times, it's a factor of 100. Now, we can do this the long way. Convert the number of atoms into moles. Divide moles by mass to get molar mass, and then we look at our periodic table and find the element. That's a long way. But we've already done this in our head. We are given that we have 10 to the 21st atoms. We know that there are 10 to the 23rd in a mole, so we have 0.01 moles, right? That's the number of moles we have. Now remember, what do we have? What are we given now? We are given mass and moles. How do we calculate molar mass? Mass divided by moles. So here's our mass divided by our number of moles, and we get 55.8. Now that's the same answer we got in our head when we simply said this is 0.01 mole. So it's 100th. So we're going to multiply this by 100. So that's our molar mass. All we have to do is find our periodic table, and we're looking for 55.8. What is it?
Iron.
Iron. Absolutely.
Could you go back to
Back to the
the
logic.
last slide?
What we did was simply do our ratio here to get the number of moles. Then it's the same thing we've done 4 times already.
I'm just trying to write it down.
Grams divided by moles is molar mass.
Okay, you can go.
All right. Now remember the hint that I just told you about identifying redox reactions. Apply that hint to this problem. What I said was, if you have an element on either side of the equation, it had to either be oxidized or reduced. It's got to be a redox reaction. If you look at this assortment, that rule makes this so simple because A, B, C, and E all have elements. So all of those must be redox, right? They must be. So you know the answer. Answer has to be D. Looks like it should be a redox reaction though, doesn't it?
Yes, it does.
It looks like it, but think about it. If oxygen is a -2, and we have 2 of them, to make NO2 neutral, this nitrogen must be +4, right? Over here, oxygen is still going to be -2. We have 4 of them, so that's 8 negatives, right? But we have 2 nitrogens. If we have 8 negatives, the nitrogen is +4. So this is not redox because the oxidation numbers don't change. Isn't that cute?
See, the way I saw it was that the last one says that was a liquid, and I thought you said that the answer has to be a solid or a gas.
Oh, no, that's in a double replacement.
Okay, thank you.
That's in a double replacement. In a redox, Simple rule is anytime you have an element, either in the reactants or the products, that is redox. Because the element has to be zero, which means it has to be something else over here.
Thank you.
All right, oxidation numbers in sodium nitrate. Really simple. We always start off with our oxygen. We know the oxygen is going to be a -2. The other rule that's very reliable is the group 1 and 2 rule. Remember, group 1 is always +1, group 2 is always +2. So we know that the sodium here, group 1, is going to be a +1. So now we can do our little mental math. We have 4 negatives here and 1 positive. In order to make it neutral, we need 3 more positives, don't we? Any questions? All right, very simple, just to see how you can remember the definitions for oxidation, reduction, blah, blah, blah. Remember, the thing that I remember, the way it works best for me, is just to remember that oxidation is loss of electrons. I would even write that down somewhere. Oxidation is loss of electrons. So we're going to look at this little half reaction here. And our question is, have we gained electrons or lost them? Well, if we've gone from 0 here, that's our oxidation state, it's an element. We're a -1 here, aren't we? So we gained an electron. If oxidation is loss of electrons, this is reduction.
I'm sorry, how did you get the 0 again for the CO2 in front?
Because, remember, it's an element.
Okay.
Elements are always 0 by definition. Always 0 by definition. All right, here we go on the other way. We have magnesium +2 going to magnesium. In order to do that, have we gained electrons or lost them? I might have this wrong. Yeah, I'm not going to show you my answer because it's long. I just sat here and just thought to myself, oh, wow, I did that wrong. So everyone has to close their eyes when I push the button. But what's happening here? To go from +2 to 0, we have to gain 2 electrons, don't we? We have to gain 2 electrons. Just like we did in the previous one with chloride. So this is also an example of a reduction. All right, everyone close your eyes. Okay. Hey. This is a very simple question on classification. You will have at least one reaction to classify on your exam. We have potassium sulfate in aqueous solution, barium nitrate in aqueous solution. We are making solid barium sulfate, and we're leaving potassium nitrate in solution. Our ions have swapped. By definition, this is a simple double replacement reaction.
Explain how it's a double again?
In a double replacement, the ions swap. So potassium paired with nitrate, barium pairs with sulfate. They replace each other. All right, which of the following is least soluble in water? We've done this poor guy to death today, haven't we? Let's just look at our options. Ammonium nitrate. This is soluble for two reasons, right? Anytime you have an ammonium solvent, anything, it's soluble, period. Anytime you have a nitrate, it's soluble. So this guy is really soluble. Barium acetate. Well, we don't know much about barium, but anytime you have an acetate salt, it's soluble. Acetate and nitrate are always soluble. Calcium chloride. We know that some chlorides can be insoluble, right? We know that. But they're limited to silver, lead, mercury, and copper 1. So this one's soluble. Barium nitrate, once again, if it's a nitrate, it is soluble. Most sulfates are soluble, except for calcium, barium, and lead. I write that on my card too.
So the answer is A.
This guy is the one that's insoluble. Any questions? All right, here we have 56.6 grams of bromine. And its molar mass is 80 grams per mole. How many moles is that? Remember when we did this in class, I told you that one of the things that you should say every night before you go to bed is what? Mass divided by molar mass is moles. Mass divided by moles is molar mass. Mass divided by molar mass is moles. Very simple things to remember. All we have to do here is take our mass, divide by the molar mass, and that's going to give us moles. Our mass is 56.6 grams. Our molar mass is 80. Obviously, grams will cancel, per mole will come up, and we'll be left with 0.707 moles. Any questions? And our very last one here. See how simple it is to go through this exam? It's a very simple table. We're given mass, we're given moles, and we want to do molar mass. What have we said 8 times now? Mass divided by moles is molar mass, right? All we have to do is take our mass, divide it by our number of moles, And this gives us a molar mass of 177. Any questions? All right, remember, the exam is going to be Wednesday. We're over in the other building. You can bring your 3x5 card. It's just the usual sort of thing. Also remember that your tutorials are due on Wednesday. So a lot of you have done most of them, and that's good. This only covers chapter 4 and 5. These are the guys. Remember, don't change the email address. Put your name in there, and it should work. Yes, hand in your sample exam, and that's 5 more points towards your total.
I know, that's what saved me the last exam. I got a third. I'll mention credits.
That's an A. I got a B, so I'll take that.
Oh, I'm gonna get it, I'll take it. Go see it exam.
No, here's a quiz.